So far, we have created an analysis project, selected a pipeline, and set up our worksets. In this video, we'll perform a test run to evaluate segmentation quality before running batch analysis. TomoAnalysis offers 3 ways to run a pipeline: test run, batch run, and history run. In this video, we focus on test run, which runs the pipeline on just one representative workset. This lets you dial in the parameters and confirm the analysis works well on your data before committing to a full batch. Batch run processes all your worksets at once and saves the results. And history run lets you revisit and review the results from a previous batch run. Test run matters because no single set of parameters fits every dataset perfectly, so a quick check on one workset can save you a lot of time later. Start by selecting one representative workset from the data list. Choose one that reflects the typical quality and characteristics of your data. With the workset selected, click Test Run at the top of the screen. This opens the Test Run view, where you can execute the pipeline and inspect each intermediate output. In the Test Run view, the pipeline is displayed on the left. Click Execute All to run the entire pipeline on this workset. At the bottom of the screen, the progress bar turns blue and advances as each process runs. If you want to see exactly what's happening, click the note icon to open a log window. It shows you which process is running and flags any warnings or errors. While the pipeline runs, let's take a moment to understand what it actually does. The pipeline panel on the left shows the entire analysis as a connected structure. At the top is the pipeline title, in this case, 3D lipid droplet per cell. Below the title sits the source, which represents the input data, the HT image from the workset we just selected. Each circle below the source is a process. Every process takes one or more inputs from earlier in the pipeline, does its specific job, like thresholding, filtering, or measurement, and produces outputs that the next processes can use. The strokes connecting them show this flow of data. The process names follow a simple pattern, a letter and a number, like A1 or E2. The letters group processes that form a chain. Each step takes the output of the previous step as its input. Knowing this structure makes it easier to read the pipeline and to find a specific process when you want to adjust it. Now let's look at what this specific pipeline does, step by step. This pipeline analyzes lipid droplets cell by cell. It works in 2 parallel tracks. One track segments the cells. The other track segments the lipid droplets. At the end, the 2 tracks are combined to assign each lipid droplet to the cell it belongs to. For cell segmentation, the pipeline finds cell centers, defines cell boundaries using refractive index and gradient information, and expands those centers outward to create individually labeled cells. For lipid droplet segmentation, the pipeline uses 2 independent pieces of evidence and only keeps regions where both agree. The first piece of evidence is shape. The TopHat filter is a morphological operation used to highlight small bright objects while suppressing uneven background intensity. After TopHat filtering, lipid droplets stand out clearly from the cellular background. The second piece of evidence is physical. Lipid droplets have a refractive index above 1.365, distinctly higher than the surrounding cytoplasm. By applying a refractive index threshold directly to the HT image, the pipeline identifies all voxels that are physically consistent with lipid droplets. The 2 masks are then combined with a logical AND operation. Only regions that appear in both masks, passing both the shape and the refractive index test, survive as lipid droplet detections. After that, a size filter removes any remaining detections that are too small to be real lipid droplets, producing the final lipid droplet label. This dual evidence approach dramatically reduces false positives. This pipeline is rule-based. It uses physical principles like refractive index contrast rather than AI models. By now, the pipeline has finished running too. In the next video, we'll look at the outputs and check the segmentation quality.